Right, hi, I'm Paul. This is my TED talk, effectively. There's not much tech in this. I thought it would just be interesting to kind of share my experience over the last, year and a bit. Sorry? Yeah. Okay. Is that about the right level? Perfect. All right. Yeah, so I thought it'd be nice to share my experience over the last year and a half. Previously, I had 18 years in software and hardware engineering. A fairly standard career trajectory, I guess. I got pretty good at engineering and then became a fairly average manager. And sort of starting from that point, the realization of that, I guess, took a few years. And now what I'm doing is I'm working as a contractor for Tourism NI, also doing some work within the Public Health Agency. And in my spare time, I run the NI COVID-19 Twitter bot, which is an unofficial bot that tweets out daily information about COVID-19 in NI, basically. There's a certain level of kind of personal catharsis and just self-indulgence, I guess, in giving this talk. It's pretty cheaper than therapy. Hopefully you guys will learn something from the things that I've been up to. I guess to start with, it's kind of a disclaimer, right? I'm in a fairly fortunate position financially and in life. You know, I've got plenty of experience in tech. I've got a good appreciation of how people use tech to do their jobs well. And at home, I've got a very supportive partner, which kind of lets me, you know, do the things I've been getting up to. So 18 months ago, I was head of engineering at Analytics Engines, for a local data analytics company. I've been there about 7 years and kind of helped to build the business from very small company to slightly larger small company. I was working hard, but I had this kind of dawning realization that I wasn't right for the job. I was doing that classic, I want to lead, I want to manage, I also want to be a developer, I also want to do things on the tech side, I want to work with customers. I was just spreading myself far too thinly, but I also wasn't really willing to change that. It's like you kind of stuck in this strain, stuck in a kind of a rut. Add to that the birth of a second child and a global pandemic, and it's kind of taking stock and just going, it's quite hard to actually admit and say, I'm not right for the role anymore. And also to then say, well, I need to let go of something that I've put a lot into. But in the end, that works out, right? It's better to accept that situation and then move on. I had a very good idea of what I didn't want, but not really much of an idea of what I did want, because I kind of felt like I'd come to the end in tech and said, I'm not sure I really want to have a career that's defined by profit and margin anymore. You know, everywhere else I worked previously, at the end of the whole chain of the things you were doing, there was always a financial piece, and that was kind of, you know, a lot of what the work was aimed at. Of course, there was many other things around it as well, but that was where it was going. And I kind of felt like I was carrying the weight of the world on my shoulders as well, to an extent, which isn't a good situation to be in. And so I kind of left up with a negative, but not really much of an idea of what I wanted to do next. So I kind of did a lot of thinking and thought, well, I want to do something that I feel is significant, and then it came down to, well, that impact, how do I impact on actual people, on their lives, you know, what can I do there? I obviously wanted to earn enough money to live on, because doing nice things only takes you so far. I wanted to try contracting, I wanted to try public sector, I wanted to contribute to open source projects, I wanted to do some things with maps, because I like maps. I wanted to do some stuff with open data, and it was kind of, that was enough for me to start kind of shaping what I wanted to do. I was lucky enough to get offered a contract with Tourism NI at the start of this year for 2 days a week, which kind of helped me to tick quite a few of those boxes immediately, and that was great. That kind of, yeah, gave me a bit of energy, got me set. Let me develop some new skills, because I've previously mainly been a coder, right, and doing architecture stuff and things like that. And I ended up doing quite a lot of work in Power BI, which is a Microsoft tool. It's very Microsoft, right? It's very clunky but very powerful. It's like PowerPoint and Excel kind of got together, had a child, and the great power of it, coming from someone who's been working in Python with Altair and Vega and DC and D3 and Angular, is that what it does well is it puts all the power of doing those things into the hands of people who don't code, right? And that's kind of terrifying in a way for coders, because you're going, well, yeah, we're kind of automated, yeah, we're the ones being automated out of a job in that situation. And it exists in the Microsoft ecosystem as well, which is really important because big organizations can kind of pick it up and use it. But anyway, I've spent quite a lot of time using that kind of tool recently. And I'd say that's a thing that's kind of come to my mind just while writing this. If you do want to solve problems in the public sector domain, either personally or via a product, you have to kind of fit to them. You have to fit their ways of working, their tools. You can go in and change things, but it's going to take you years. So anyway, to do contracting, I set up a limited company to do contracting. If anyone's interested in that kind of thing, have a chat with me afterwards, because once you've done it once, you kind of you figure out what you want to do. It is quite easy as long as you read around it a bit, and as long as you're prepared to hand over a bit of control to people like accountants and solicitors who do the difficult bits for you and let you just concentrate on doing stuff that you really want to get out of it. If you don't want the hassle of doing that, go to a company that handles contracts. So yeah, anyway, I'm kind of burbling slightly. The next thing I did, so that sort of sorted me out for 2 days a week, and I felt like I was going to learn a lot, and I have been learning a lot. The other thing I wanted to do was kind of contribute a bit. So I signed up for the Department of Health's COVID workforce appeal, which ran back in January. Originally it ran to find nursing staff, because there's a panic, we need more nursing staff, we need people on the ground. So they brought back a lot of people who'd previously been in nursing, but then they started to expand that as they found other areas where they needed people. One of the areas they needed people was data analysis. I thought, this is perfect, so I can come in. One of the things I've found about the public sector was it's hard to get into the public sector without having some public sector experience. This was an opportunity for me to work with COVID data that I found really interesting at the time, and get some experience in a domain I really wanted to work in. I kind of became obsessed for a while with COVID data. I think it was my way of kind of dealing with the situation, was to feel like you have some control by staring at graphs. I'll come back to that in a minute, but going in on the workforce field basically meant I was working a couple of days a week in a graduate level position within the public health agency, which was great to kind of see where things were happening, see what was going on, and learn a lot. But it's a definite lesson in humility, right? If you're coming in from the private sector, and people, the organisation is in the private sector is usually geared around getting you to do your job well and supporting you and all those things, whereas the public sector was much more of a machine that I had to learn how to fit into. I spent a lot of the early weeks trying and failing to get tools that probably most people here would consider to be basic kind of survival needs for doing the things you need to do, and then failing to get those, and then kind of finding out what the limits of a very limited technical architecture are, and then saying, right, at that point I think I was like, do I stick with this, or do I stick in this situation where it's going to be hard for me to do stuff? And I am. It became an exercise in minimalist kind of engineering. It's like, what is the least that I can actually have that I can do a meaningful job of reasonable quality? Because at that point there's no version control, no CI, no collaboration tools, no programming frameworks. How far can I cut this back before I'm effectively useless? But because I'm odd and wired slightly strangely, I was completely hooked by this. I was like, this is a really interesting challenge, and because it's such a great domain, I was like, I'm definitely in here. But as a kind of slight, to go back to the data side of it a bit, I built a Twitter bot. I think this was partly because I was frustrated going through different sites, dashboards, reports, PDFs, spreadsheets and things, just trying to find out information. My wife kept saying, what percentage of the population are vaccinated today? When am I going to get my vaccine, right? This is a thing in our house for a while. So I put together a Twitter bot that kind of gave me the information I wanted. It was written in Python, built on AWS, and it was very educational for me. And it's also, I think, taught me quite a lot about how to communicate directly and succinctly about data. It's really difficult to try and summarize a load of complicated information into 280 characters that are going to go out every day. and make it so that it's relevant and doesn't feel like it's a machine. I'm not sure if I've achieved that really, because I'm not exactly a minimalist in the way I do things, but I think that there's a sort of small group of people now who seem to appreciate it and like it, and it's quite nice to sort of operate a little service for the sake of the service, rather than operating a service and worrying about marketing it or getting a rate of return from it. The return is purely just in the doing of it. And I think it also helped me in terms of, I was in a role where I couldn't use my coding skills very well at that point because there wasn't anything to use them on. So anyway, the bot happened, it's still going, it's still there doing its mad things occasionally. And my contract with PHA ran till the early summer. And I was so hooked, it took me 3 different job applications, 2 interviews, and an agency to actually find a way back in. But now I'm working quite closely with the original department, but I'm actually on a more modern architecture, hosted on Azure. So I've got all these tools that I've got access to. You know, I've got Azure boards, I've got Git repos, I've got pipelines, I've got all the things that you kind of associate with being able to do modern data or software work. But I think the thing that I've found the most powerful, having everything taken away and then having it all brought back, is actually Kanban boards. Like the ability to collaborate with colleagues on things is really transformative. And definitely that piece of effective collaboration really trumps having version control and CI. I'm not saying you shouldn't have all these things, but I'm saying if you have to choose one. So it's a lightning talk, right? So I'm going to end with my TED Talk inspirational message. I'm going to say, if you aren't happy at work, change it, do something. It is tough sometimes to change it, but do it for the right reasons and try and do it for a positive rather than negative. Always try and work with domain experts. I think, probably everyone here is a domain expert already. And you kind of identify how hard it is to be a domain expert in whatever domain you're in, and always try and find those people to work with to help you along the way. Definitely in Belfast at the moment, in software and data, it's an employees market, which is great. But bear in mind there's other things to optimize for other than your salary, right? There's other approaches you can take. Effective collaboration beats the best tools in the business, and if you're going to be in the public sector, Microsoft's got those guys locked in, and in many cases it is for good reasons. That is really everything I want to say, so thank you for listening. Thank you for the organisers. Thank you very much. You get a mix. Yeah, sorry. So my interpretation of the question was, did I get any pushback on the official side for doing the Twitter bot, or did I get any support, right? Or any people saying, well, yeah, there's a definite mix. I think there's a lot of people who are very open to the idea of open data and sharing that information and letting people do that. And there's also a group of people who aren't very open to it. I think because I've been in embarrassing situations already because of the bot and my day job. And I do occasionally sort of turn bright red on a Zoom call when somebody starts talking about how terrible open data is and the fact there's all these people on Twitter misinterpreting things. But it kind of helps in a way for me, because you have to have a really laser-like focus on making sure everything's right. Because my biggest fear isn't that somebody's going to call me out for presenting something that's already in the public domain. My biggest fear is I'm going to get something wrong, and somebody's going to somebody's going to sort of hit onto it and start sharing it because it's wrong, or because it shows things in a light that they're not supposed to be shown in. Does that make sense? Yeah. Basically, an organisation that isn't used to software development, so an organisation that's existed pretty much entirely without doing any kind of software development internally whatsoever, and obviously consumes things that people have built, but hasn't ever run a make type of command themselves, and then having a extremely secure lockdown IT environment where there's a huge amount of nervousness around open source software, for instance. The idea that somebody could contribute something to an open source package that could then be installed on a machine within the firewall. That kind of situation where you can't actually install anything on your PC. Somebody installs things for you. Yeah, that's the sort of level of control over the situation. So you end up building things out of Excel, Access, and SharePoint because they're the three things that you actually have. Yeah. 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 Oh, we've got one more. Sorry. Hi. How do I get to what, sorry? I didn't really market it at all. I kind of shared it out on my personal social media and LinkedIn and a couple of things like that, and it was really, I quite like watching things tick up steadily. It's very interesting to see how these things grow, and it's basically it seemed like you get an inflection point every couple of weeks where somebody with a large following notices something, retweets it with a comment, and then suddenly you get a nice big burst of followers, which is quite exciting. Like free internet points, and your phone keeps going ding, 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 ding for a couple of hours, and then it settles down again. Okay, thank you very much, everybody.
Thanks so much, Paul. So next up, familiar face, we have Laughlin. He's principal software engineer in Rapid7, and he's about to talk to us about building an ESLint role. Hope I got that right.
Oh yeah, cool. I'm not talking too loud, let me know. So yeah, so we had a last minute cancellation, so now you have to listen to me instead of whoever that person was going to be. But sure, it'll be fine, it'll be grand. I did the slides on the bus, practiced it on the bus. I'm getting all excuses out of the way. I was losing my voice, but my voice sounds better now, so I've lost that excuse. So obviously, we all know how we can skip that slide. So, I don't know about you, but I'm a normal developer. And when I build something, sometimes it isn't the best. There's project deadlines, customer constraints, you have a bug that you need to get out immediately, so you just write a bit of really bad, crappy code and push it out. And then you add a little comment above that code saying, to do, fix this later. And if you're like me, you probably never went back and fixed that bit of code, because who has the time to do that? So, unlike other people who go mountain biking at the weekends, or swimming with dolphins and have all these hobbies and interests, I don't have any other hobbies. All I like to do is think about code, how can I build things, and how can I make solutions with the different things I have. So I was like, I left so many to-dos in our project, like, what can I do? I know I'm going to go back and fix them. How can I go back and fix these problems? It got me thinking, right, there's tools, there's solutions, there's things I play about with. I can learn something here, and I can build something at the same time. So the first thing that came to mind was like ESLint and using ASTs. We'll get into the details of what they are in a minute, but I kind of thought about ESLint as if you're a UI developer who works on a small to medium to large project, you've probably either used ESLint and not know about it, or you've configured ESLint, or you've done something with ESLint. You set it and forget it, runs in the background, you set a bunch of rules, the correct rules, obviously, single quotes, 4 spaces for your tabs. That's the way all developers should be building the products. We'll get past that. So I was like, well, a lot of people build it, set it, forget it. Well, how does it work? How does it run? ESLint's built up of a number of different rules. They give standard rules. You can install rules for React, Angular, Vue, TypeScript, whatever. Maybe you're using Prettier with ESLint under the hood. I was kind of thinking, how can I learn more about this? How can I do something to kind of solve my problem? And I wanted to also learn about ASTs. How can I kind of dig into this a bit more? So an AST is an abstract syntax tree. Sounds really complicated, but it's just fancy words for things that we use and know about every day. So first I need to learn about how these things work before I can actually use them to solve my problem. So let's look at a very basic example of what an AST is. And this is what the likes of ESLint and Babel and stuff are built off. So look enough, I have little examples here. This is going to be very bright. I hope you can read that. Let me zoom in a little bit. So this is Ast Explorer. It's an online tool that you can put code into, and it will generate an AST, and it allows you to do multiple other things. But in the bare bones, you have code on the left and AST on the right. Now, we still haven't really explained what an AST is, and this is a word you might not have heard before. If you have, then you can kind of zoom out at this part of it. But an AST is a way of describing what code looks like. Now, it's really hard to kind of say, I want to describe what code looks like when I can look at the screen and see the code there. But what if I want to interact with it, understand it, do things with the code? So we can turn it into an AST. An AST is just there's 2 tabs here, tree and JSON. The JSON is just this is a JSON object that describes what the code looks like. The line numbers, what the type of the bit of code is. But this little tree thing, it's a bit prettier and nicer, and it does highlight and stuff like that. Things that I could probably never build if I made a web application. So we can hover over, and we can see this is our program. This is the entire file that we're looking at. We dig in, we can see our program has a body. It has an import declaration, a variable declaration, an export declaration. We can dig in, so this is how it's understanding how we imported React. We're using React. We go into our variable. Variable has an arrow function. Inside of our arrow function, we have block statement, a return statement. So it's a way of looking at code, understanding the code, so then we can do things with the code. Now, we haven't touched the code yet to do anything. We're just looking at it and trying to understand it. So this is kind of interesting. This is cool, for me at least anyway. So let's kind of move on a little bit more in advance. So like I mentioned, tools like ESLint and Babel use these abstract syntax trees to do things. Again, if you're working on a medium to large web application, you're probably running Babel or Webpack or some sort of tool that transpiles your code from ES6, 7, 8, 1 million into code that can work on whatever browser you're working with. If you're working with Internet Explorer, it can transpile it down the code that will never run on anyone's machine because it's terrible. But we can play about with these things. So let's look at an example using Babel to transpile our code. Okay, we're cool, we're still zoomed in, we're good. So there's a lot more going on here. We don't have got the 2 panels anymore, we've got 4. So again, the top 2 are code, our AST. Now our bottom 2 is now we have that transform, and then we have the output, what happens in the transform. So I think I can zoom in. So this is our transform code. There's a lot going on, but you kind of have to understand the basis of it. There's a visitor pattern, and you say I want to look at this part of the code, and then I want to do something with that code. So we're saying, give me every identifier, and then I'm going to do something with that identifier. And in this example, we're reversing the text of that identifier. But what is an identifier? So let's look through our tree, and we can go variable declaration, declaration again, and we go identifier. So identifier is the name of the variable. So we can say, for every variable name, give me that variable name and let me do something with it. In this example, we're reversing the variable name. Not very useful. It'd be very fun to run on someone's code base and commit it and then see how they can understand and read that code afterwards. But we've now taken that code, done something with that code, and we have a different result coming out of it. So we're using that AST, we're processing, we're actually doing something instead of just looking at the code. But then again, this hasn't solved our to do come back and fix later solution. So how does ESLint work and how does ESLint rules work? So we've learned AST, we've learned transformation of code. Let's dig into how ESLint works. And again, we've got our two sections, our code, our tree. We have a transformer. ESLint is a transformer. It doesn't always have to transform the code. It's more of inspection of the code. So we pinch the zoom again. So in this case, now I'm saying, give me every variable declaration, and then I'm inspecting it. So I'm saying, what kind of variable is this? If it's a let variable, then I'm going to call context.report. And context.report is how ESLint triggers a message back to the terminal. So if you've ever ran ESLint in your code base and it complains about a missing semicolon, or you haven't got a new line after a return statement, this is how you send that message back. So it's looking at the code, triggering the message. So in this case now, we've written a rule that says you can't use let in your application. Again, not a very useful rule, I don't think I'll ever use it. But we've like stepped up another level, and then we look over here, we can see this is the output from ESLint. Lets can't be used, even highlights the line, shows us the line where let is. We haven't transformed the code, we just analyze the code. Now there is the ability to do autofixes in ESLint, which we'll not get into because that complicates things more, but you actually can transform the code based on the rule that you're executing. But for this, we just want to inspect the code. So again, we're kind of getting close to like how do I fix my laziness to never go back and fix the code that I badly written the first time. Well, then I kind of got thinking, right, so I always had a comment that I'm going to go back and fix it, but I'm never going to go back and fix it. What if I set myself a due date? So I say, by this date, this code should be fixed, and if it isn't fixed, then fail the build. So I can't compile the code if this rule is hit. So I was thinking in my head, right, let's create a pattern. You have a comment, to do, a message, and then a date where it has to be done by. So I can kind of set these little time bombs in my code base that I can come back and it'll force me to fix it later. So let's take a look at how we could build up that rule if we were going to do this as an ESLint rule. So first things first, we need to create a rule, set up a rule. So there's a bit of boilerplate around ESLint rules and how you can configure them. More or less, the gist is like, let's give it a name, time bomb. We say we want to look at the program. So if we remember from earlier in our AST, let me jump back in actually. If we jump back in our AST, we can say like the program. So that's the entire file we're looking at. The entire thing has been passed to ESLint. So we say we care about the program, and then we want to do something on that program. So it gives us a node, and the node is that the JSON node or the object node that existed for that identifier. So from then we can say, right, well, give me all the comments that belong to that program. So that's all the comments in that entire file. So we can iterate through those, and we can log them out. And that's going to log out all our comments, because some comments are going to be, we divide this by 0 because the customer says that's the way we should do it. Or, I did this code at 4 a.m. while drinking a glass of wine, let's review this again tomorrow. So there's going to be rules that aren't time bombs. So then we kind of step things up a bit. We add a lot more code in this going on. But we can walk through this and talk about it. So at the very top, we've now added in a regex just to find our comment, because our comment's a to-do, message, date. I copy and pasted this from a regex generator. It probably is very brittle and will never work again, but regex is impossible. Nobody really knows how to work it. And then we kind of do a little bit more with our comments. So we're not just iterating over and logging them out now, we're iterating over and saying, right, does this match our regex? And if it does, then we're going to create a date object. And then normally I wanted to stick with like 0 dependencies, so the date has to be in American format because that's the way the native date object works. Unless there's another way to use it, and I haven't checked it yet. But this is a late night project. On the bus, obviously, on the way here. So we grab that date, then we say, let's grab today's date. If the day's date is ahead of our due date, then we've caused our error and we've broken the rule. So then we say, right, our comment's at a date, but then obviously that's not going to do anything because we need to help ESLint to like throw an error or do something. So the next step is then we trigger our context report. So we can say, trigger a report, throw an error, stop the compilation, break the build. So now we've kind of built up the system where like I can put a comment into a file, say this has to be completed by this date, or the build's not going to complete. Now, you're probably thinking to yourself, well, if the build fails, I'm just going to delete that comment. I was going to build some sort of fancy solution that could fix that for you too, but if I seen a PR going through where someone removed the due date and didn't actually fix the code below it, then I would reject the PR anyway for that kind of sense. To configure this then, we just deployed the npm and imported the ESLint config. The same way you use any other rule. So like, There's rules for React, there's rules for Angular. So we're saying time bomb, and we're saying time bomb slash time bomb. Annoyingly, a plugin can have multiple rules, and I didn't think about this ahead of time in the way that it was all named. So it's time bomb slash time bomb, which is really repetitive, but it's a joke thing that if I do introduce in my project, it'll probably get rejected. And when we run it, it fails. Now we can't continue on. We have to fix that code that we said we were originally going to fix all along. Thank you very much. Any questions? So I'll summarize the question for the stream. Yeah, so like, can ESLint track state over multiple builds and could potentially manage it some way like that? What I quickly learned, the beauty about this is, because a lot of people look at like ESLint and they're like, it's this magical thing that runs in my application and I don't have a clue how it works. It's just JavaScript that runs in a node process. So there's nothing stopping this ESLint rule from talking to an external database, manage the state there, or maybe if there was like some sort of local state on the machine you're running on, it could build up a history there, because it's just JavaScript that can talk like, no, well, you want to have side effects from an ESLint rule is probably not best practices, but potentially, yeah, you could do that. Awesome, thank you very much. So we're going to take a little 5-minute break. Stretch your legs, go for an eco break or whatever, and then we'll be back after the break with Neil. Thank you very much. Welcome back everyone from your break. So our final speaker tonight is Neil. Should be a very familiar face, ex-organizer of BelfastJS. It's an honor to introduce him onto the stage because he's introduced me onto the stage multiple times. Take it away.
Thanks, Chris. Thanks, Louise. Thanks to BelfastJS and NIDC for having me tonight. Can you all hear me okay? Yeah? Or will just give me a hand setting if it doesn't work. Good to see so many familiar foreheads, I guess. This is my first time giving a in-person talk for quite a while, so if I seem a bit nervous, I am. I'm going to set a timer as well because I don't want to go too long. So we're here at BelfastJS. I assume most of you are here because you want to build something or you like to build things, right? That's definitely right why I'm here. Paul's talk earlier resonated with me for a number of reasons, not least of which is the fact that I too find myself in more of a managerial role at work these days. I like it, it's great. I think the people part of the business is very rewarding, but I'm still an engineer at heart, and so I look to build things where I can, either in work or more recently in side projects, and I tend to do that in the browser, in the web, because A, it's what I'm familiar with. I've been a JavaScript engineer in some form for longer than I care to mention, but also because the browser is a very, it's an extremely complex creative platform if you know how to use it properly, and so I look to build things where I can. I've also got more interested recently. I was talking about this just before I came in, actually. World building is something that's kind of come to me in the past little while, particularly during lockdown. I had dabbled in Dungeons & Dragons and other kind of role-playing games before the pandemic hit, but my group obviously had a lot more time on our hands once we were in lockdown, and so via Zoom and a bunch of other tools we were using, we got to essentially build a world together. It started small and it's just expanded from small dungeons and taverns right the way up to cities and entire continents. And it's all in our heads, right? We use some visual tools, obviously like the occasional map or some visual aid, but all this is going on in our heads, and all we really have is our speech to kind of maintain this world and build this world in our heads together. I do try to keep up with video gaming too, though, when I can, when I have time. I had a crack at Halo Infinite last night. Anyone else played it yet, or had a go at it? Yeah. I don't do multiplayer, Paul, because I suck at it, but I tried the training mode, and as always, I'm blown away by just the fidelity of the visuals and the world that they can build for us just on the screen there, incredible mountains and skies, and just takes your breath away. I'm always reminded of how far the medium has come. The farther back you go over the decades, it almost becomes like a deconstruction of reality, or at least an abstraction. Things become increasingly blocky, increasingly kind of representational, until you get to the point, we're going back maybe 40 years now, where there were no graphics, and text was the only thing that the sort of fledgling game developers had to work with back then. They had to make their text work for them and to build that world and to develop that world for us with nothing more than the words on the page. So it's with these disparate thoughts in mind that I want to talk a bit about how we can possibly build a world in text in the browser, and hopefully learn a few things along the way. I'm Neil. I'm a development manager at Lightspeed, working in the payment sector. I'm NGM code on GitHub and Twitter and CodePen and other places. Welcome to Go North, Get Sword, making text games on the web. So let's get our terminology in order first. Text games is kind of a all-encompassing term, and obviously with a genre that has as much history as that, which we'll talk about in a second, there's been a lot of different terms for it. I tend to separate them broadly into two different categories, one being kind of choice-based and one being parser-based. Choice-based is what you would know maybe as kind of a choose-your-own-adventure. We'll show an example in a second. They've been called gamebook style because a lot of paperback gamebooks of this nature were published. Visual novels are kind of in the same spectrum, but they, by definition, have more graphics. Hypertext fiction kind of became common at the dawn of the web, and I searched on the Steam store before I came down here, and there's about 300 sort of text adventure games on Steam right now, which are largely seemingly of this kind of choice-based variety. Also, our venerable host, Chris Laughlin, did a live stream on building a choice-based text adventure a while ago, which, Chris, you can plug at the end of the talk if you've got time. The other side of the coin then is what I call parser-based, or text adventures. It's most commonly known now as interactive fiction. The gameplay loop is kind of pretty much similar to, in both cases. The computer, it's turn-based. The computer describes the location you're in and any interesting items. You're prompted to make a decision, and then the game narrates the outcome. And again, it kind of harks back to that kind of Dungeon Master kind of vibe. You know, the DM narrates the scenario, and the players decide what to do. The main difference is that in a choice-based game, your choices are immutable. They're presented to you by the system itself, and you basically pick from a multiple choice quiz, whereas in a parser-based, you're provided a command line, and through typing commands and verbs and nouns, you're able to interface with the game and make the story go forward. Just by show of hands, many people have played one or more of these types of games before. Okay, so fair enough amount. To do the genre history justice would be probably several talks, but in very brief sum, it was born in the 60s in natural language processing research on early mainframe computers. ELIZA and other kind of chatbots, almost like psychotherapy bots, kind of came out, which basically gave the impression of intelligence by parroting back to you what you typed in kind of form of a question. But it quickly developed. A lot of very smart people in these universities got their hands on these mainframes and decided to translate their love of their hobbies, be it role-playing games or cave exploration or the works of Tolkien, into these interactive early text adventures, which blew up into a whole commercial sector. Became a mainstay of the computing scene right the way through the 80s when the home computer revolution kind of started. People had Commodore 64s, Amstrads in their home. They had BASIC built in. One of the first things you could easily develop for yourself was a text adventure. In the 90s, it started to wane a little bit because obviously we're starting to get multimedia, 3D graphics, and the notion that someone would sit in front of a computer scrolling pages of text and typing stuff into a text box seemed insane. Then, of course, the internet happened, and the whole genre kind of got a resurgence, albeit not so much commercial, more kind of community-based. And so we find ourselves here today with still a very healthy, thriving community. A lot of commercial products are starting to come out in this format, albeit with different embellishments. There's a really interesting strain of research on how machine learning and AI and procedural generation can apply to these genres. There's a ton of really good tools that can be used. So, you know, that's a very, very short history of it. So I will, before we go any further, briefly demo one such game, hopefully, if it works. Where am I? What's the tab? Here we go. So I didn't collaborate with Chris before we decided these talks, and I too have a time bomb in my talk, except this is a very stereotypical kind of comedy explosive in the corner of the room. So the game describes the situation to you. We're trapped in a basement, no means of escape. The floor is covered in rubbish. Oh no, there's a time bomb in the corner. Now these games are turn-based. The game's not going to advance in any way until I give it a command. I guess there's a bomb here. I guess I better examine the bomb. The timer's counting down. There's a wire attached to it. Things look bad. Can I just defuse the bomb? How am I going to do that? And it seems like the counter is still counting down. What about this wire? A single red wire between the timer. Okay, I'm going to pull the wire and hopefully that will defuse the bomb. Looks promising. Oh, okay. So that didn't go so well. We'll revisit that at the end of the talk if we have time to see whether maybe with your help I can defuse this explosive. But that's a sort of prototypical example of how a text adventure interface works. You type commands and the game narrates the outcome and there are returns happening in the background. Why would I want to build my own, or why would I want to build something like that? I'll revisit the slide at the end just to kind of recap what we've done, but the main reason is that it's got a pretty low barrier to entry. It is just text after all. I'm not much of a graphic artist, and there's no real overhead to creating assets like it would be with other games. You don't have to create 3D models or pixel art, you just have to start typing text into your screen and get results that way. There's also some really interesting coding problems to solve, or at least to explore for yourself around text adventures. Many of them are solved problems, obviously, given the history of the genre, but as an engineer and as a developer, it could be a really interesting space for you to play around in. And obviously, with the web being a text-based still kind of format and a text-based platform, it's naturally suited to take on these kind of projects, and obviously distributing these projects is as easy as just uploading them. And also, it's fun. It's my kind of fun, anyway. So when I'm doing a side project, I like to set a bit of parameters around what I'm trying to achieve here, so as not to go too far off track. Admittedly, a lot of these were applied retrospectively. I didn't really think of all this at the time, but if I was to have gone back in time and described what I wanted for my JavaScript project, it would have been, well, first of all, JavaScript. A lot of the tools that have been invented over the years and decades for these interactive fiction games are essentially domain-specific languages. There are obviously frameworks available for most of the big platforms and languages anyway, but a lot of the popular ones are aimed at non-developers, and so they're a mixture of plain English and other strange kind of semi-syntactical languages that these non-technicians create these worlds. Obviously, I'm a JavaScript engineer. That's what I'm interested in. That's what I wanted to explore the power of, so I'm going to make sure this is JavaScript-centric. Also, not to cause any controversy, I really like TypeScript. We use it at scale extensively every day in Lightspeed, but I don't really want to set it up for my personal side project. I want to just be able to play with the built-in JavaScript and see what we can do there, and keep it a casual dev experience. At the same token, I don't want to have to set up a massive big Webpack build chain or anything like that. Just hopefully do a single install, do a bit of configuration, and then just start getting on with the business and making the game and the engine. Other things are just like, I want to be text-centric. A lot of these so-called text adventures end up slapping a bunch of graphical effects onto the top of the text, which I understand. You know, it's a hard sell to give anyone a screen full of text as a game in any era, really, but I want to just focus on the text and not get bogged down in graphics, that kind of thing. And make sure that it's quick to author with, that I, as a game developer, can not only work on the engine quickly, but also when I want to start building these games, I can very rapidly turn it around. And make sure there's minimal API surface. I don't want to have to create hooks and ways into the engine for every single eventuality, just enough to make sure that it's something I can script and make it a fun game with, and make it fun. So let's get the basics out of the way first. I haven't used any UI frameworks for this. Obviously, you could in your own project. You could by all means spin up a React app or any other, whatever your framework of choice is. I've literally just went for a form in a web page with a submit handler attached by JavaScript. Having the form means that we get ender on submit for free. We don't need to do any weird scripting around that. By the same token, the output is not any kind of fancy UI toolkit. It's just literally injecting paragraphs into a div constantly, and the screen just scrolls down the page as we type. For code bundling, I avoided Webpack, not because I don't like Webpack, but just because I'm trying to keep things light. So I went for Parcel, which is one bundler for the actual building the games that are consuming the library. For actually bundling the library itself, I need something more specific. So there's a micro bundle, which is a nice package, which just lets you, with almost zero config, be able to build your library in many different formats, UMD, CommonJS, other things, and output them to a library folder where I can then just consume them for my games. So yeah, so the UI is nothing more than a bit of HTML and the JavaScript listener. Obviously what goes on inside the submit handler is the important part, but the general loop is that we get what the player has typed, we parse it in some way, we update the game state, and then echo the result back, and that's what you're seeing when I'm typing these commands here. The engine has got some commands built in, which you saw me using. These are the built-in ones, fairly standard stuff. Internally, they have aliases applied, so I don't have to keep typing the same word every time. A lot of the issues around text adventure development and interactive fiction is the quality of the parser. And a lot of that is to do with basically what dictionary it has and what kind of words you know. At the worst, these games can devolve into a game of guess the verb, which is not really the gameplay we want to present to the player here. We want to be able to focus on whether it's a puzzle or the story that you're creating, not have them typing random things into a command prompt trying to figure out which is the magic word to move the story forward. So the more aliases we can provide for our commands, the better, and they're defined internally like this. The player can also, or the author rather, can create their own commands later on, which we'll get to. In terms of actually invoking the engine, it's a one-file import, and the entities, as in the game objects, be they locations or items or whatever, are just plain JavaScript functions that return an object literal. They get decorated and mutated on the inside of the engine to do what needs to be done, but in terms of actually authoring, you just need to create these entities and then call engine.start. You pass the entities in. There's a couple of optional configuration items like the starting state of the player. You can define your own commands, and there are a bunch of logic callbacks to hook into different parts of the game logic, so you can start to write your own custom logic for things like puzzles, locked doors, that kind of thing. We'll get to that in a second. So the main coding challenges beyond those basics in these games are obviously how do we define the entities in our game, how do we describe a location, an item, a piece of scenery, that kind of thing. Actually parsing the user input, what does the user want to do? We receive what they type into the text box, how do we know what their intentions are? And then being able to let the authors also write custom logic to define their games for the players to play. Let's look at the first one, defining game data. And entities, as I call them, are really everything in the game world that the player can interact with. They're the locations you're standing in, they're the items you can pick up, scenery that provides incidental detail, and anything else we call a game object. As far as the author is concerned, they just have to, as I said, declare a JavaScript function that returns an object literal. The keys in that object on the left are just they're everything that the player can interact with. There's a few string tokens for things like descriptive text and summaries, an array or two for describing some nouns for that object, some tags that are hints to the engine to say this is an item or this should be hidden, that kind of thing, and the data object, which basically is just a store for random data that the author can use. These objects will get frozen or rather sealed in JavaScript whenever they're imported into the engine, so this just prevents any unnecessary mutations that we don't want at runtime. Internally, there's a bit of jank going on. JavaScript object literals can't self-reference when you're creating them, but obviously it would be important for the author to be able to refer to the object internally and be able to say, okay, well, I want this object's data to print out as part of their description or something. So the weird 3 lines at the top of the right-hand panel there are just really me for declaring an entity variable, creating a function that will return that variable, and then passing that into the entity function. We'll get to it when we get to the actual entity definitions, but basically what it means is that you can call that function inside the entities when you're declaring them and be able to refer to its internal state to put into a template literal or something and define how the entity describes itself whenever it's being printed. The rest of it is just metadata for things like, has this entity been examined first? Has it been moved at all? How many times have we visited this location? Which authors can use in their logic to make certain things happen. So locations then, we need to define a game world to move around in. This is probably the most straightforward way to define a map. Just create, again, a couple of functions that return object literals. IDs have to be unique. They were referred to internally and also by game logic. Summary is, well, so the description is printed when you first arrive at a location, and also if you use the look command, it describes the full location to you. The summary is what will be printed if you return to a location having previously been there, just to kind of, you don't want to bombard the user with a bunch of text they've already read. If they want to read it again, they can type look and see what else is going on. This is just a summary. And to define connections between the locations, we have a to object, which just is a noun and ID key value pairs. So you can see the tavern, if you go north from the tavern, you hit the kitchen, and if you go south from the kitchen, you hit the tavern again. And in practice, that's what it looks like on the screen. We go north from the tavern, we're seeing the descriptions for both of them because it's the first time visiting. If we try to go north from the kitchen, we can't go that way, there's no connection. So back down south, we get the summary. Looking will print the full description again. So we don't want to bombard the player with a bunch of text up front, but if the player does want to drill in more on some of the scenery, we want to be able to give them that information. And so scenery, as I define it, is just an entity that will live inside a location. It doesn't say or report itself in any way until the player examines it. So in this case, we've got the kitchen again, but we've added something to its things array. In this case, an entity called old food, which just has a description and some nouns. If the player then is standing in the kitchen and does examine meat or examines vegetables, it will get the description that we provided for the old food. It just means that you can flavor the world with a lot more detail. Expect players to try to examine everything in the scene, even if you mention something in the description of the location. If you haven't provided some scenery for that, the game will just say, I can't see that, which will kind of be a janky experience. So it's pretty easy to spin this stuff up. It's just scenery flavor, really. So in this case, we're in the kitchen, we examine the meats, we get the description, but we can't take it because it's not defined as an item, it's just some incidental scenery. We do want to be able to pick up items though in the game. A core part of the gameplay loop is finding items and the right place to use them or how. So in the tavern again, we've added a tankard entity into the things array, which means it lives inside the tavern. The tankard is defined much the same as a regular entity location, but it's got an item tag on it, which changes its behavior internally. For the location to report what's in the location when you visit it, it will print its description and then say you can see and list any items that are there that's visible. So it uses the summary for that, so it will say you can see a tankard. And if we examine the tankard, either after or before we picked it up, it will use the tankard's description. So again, using these object literals and fairly simple definition syntax, we're just slinging JavaScript objects around here. We're already starting to build up the basis of interaction and how we can describe objects and start to build this world around us. The thing though is that you can see a tankard. That's fine for a plain tankard, but let's say you're in the final screen, the final stage of the game or the final room, and your quest object was there, I don't know, the amulet of Yendor or something. To describe this location and then just say you can see an amulet doesn't feel particularly grand. So there's kind of an extra optional definition in the engine where you can define an initial description for an item, which will be printed if you enter this location and it hasn't been moved in any way. So in this case, we just describe the tankard in the same way we did before, but we give an initial description mentioning that the tankard is on the table. So when the player goes to that location, second line there's a tankard to be on the table. If the player subsequently takes it and puts it down again, the engine will forget the initial and just say you can see a tankard again. Maybe the player just literally dumped it on the floor. But for now, that just gives us more of a narratively interesting way to define a better description for items when we first encounter them. So as I mentioned, we want the entities to be dynamic in some way. These static descriptions can, they're not going to be particularly interesting to play with over time. There's a couple of conceits in the engine that authors can use to make this more interesting. Firstly, descriptions can be more than one line. You can provide either a string, a function, or an array of either to most of these properties, and the engine will parse them out. For an array, it just prints one paragraph for each item in there. For functions, it will obviously call the function, get the string back from that, and then print that first. So that's where we can start to use things like eternal entity state to make items more dynamic. So the tankard down below, you see we're passing into the function getThis, which was the kind of self-reference function we mentioned earlier. And it means that in the description, since we're calling that as a function now, it's a template literal where we're interpolating some of the object's local state into it. So that will get called every time we need to print the description of the tankard. So if the state changes in some way, the description will reflect that. And so you can start to build up more dynamic objects that respond to what the player's doing. So in this case, well, first of all, you can see that the engine has printed the first 3 paragraphs because it was an array of strings. The player picks up the tankard and examines it. It says that it's full. If, hypothetically speaking, there was a command in the game to drink the tankard or change the state in some way, we would change the state internally to the tankard's empty. And when we examine it again, using that same description code, the tankard never reports it as empty. So that's a nice way to kind of get some interactivity and some kind of dynamic descriptions into the game objects. So just under the hood in the engine itself, this actual engine code, when you go into a location, we call it a look function, and it does a number of things. First of all, it has to decide whether you're coming to the location for the first time, so we can decide whether to print the description or the summary. There's also an override that you can set for, if the player actively says look, we can just use this function and override this logic. It prints whether either the summary or the description. If there's nothing in the location, i.e. if there's nothing in its things set, then we just bomb out there, but otherwise we filter the items that are there to make sure we can describe them. There's some tags internally that will items, for example, will get described, like you can see a tankard, but things without an item tag won't be, like scenery, for example. So basically this code is just building up a list of what we should describe as part of the location. We will handle the initial descriptions, and then we just print a list. Get summary list text at the bottom there is just literally doing a comma join on the array, and prints out, you can see the tankard, piece of rope, whatever else. So if that's how we define our game entities and how the author can start to build a game world, it's actually a pretty good setup with mostly just minimal JavaScript that we're used to. We can define the entities as regular JavaScript objects that return literals, like a self-reference. We've got different text items that will be used contextually. And yeah, so it's a pretty good setup for how to build a world. What does a player actually want to do with the world? That's the next kind of thing to consider and work with, parsing user input. So the parser is the way that the player interacts with the world, and so, like I mentioned, if the parser isn't good or they haven't thought of everything, things will get old pretty fast. Over the history of text adventures, they've gone from very simple, literally just verb-noun pairs, up to NLP, just the full natural language, machine learning, all kinds of things. I'm aiming for somewhere in the first sort of 3 areas, the first 3 items on that list. Not something which is completely just verb-noun, but something which actually under the hood is much like that. It just has the appearance when you type it of being a bit more intelligent. That could just be a giant regex, but there are things fortunately out there that will help us achieve this. So Compromise is a library run by a person named Spencer Kelly. It's a natural language processing framework for a library for JavaScript, which is predicated on the notion of it being good enough, which I guess hence the name. The main kind of mind-blowing fact is that using kind of like an 80-20 rule for language, the top 100 words of English are 80% of written speech or written language. And so with a bit of extra kind of extrapolation and some good assumptions being made, you can very quickly get up to covering a very large amount of the English language and putting it into a library in a way that has a pretty massive dictionary. It's got 14,000 words in the base dictionary, but the minified file size is about 170 kilobytes, which is pretty bonkers for everything that's in there. They do a lot of really cool compression and rehydration on the client to make that happen. You can feed it some text and pull out everything from the different subjects, verbs, nouns, the tenses. You can change tenses, you can pick apart sentences. It's very powerful, and it's actually fast enough to be used on type. They demonstrate it on the website. You can start typing in text and it will, in real time, essentially analyze the text for you. That's obviously something that's really useful for this application here, and I've used it inside the engine. It's literally a one-line import. You feed it some text, and then by calling, the APIs in this version is slightly janky. You have to do that kind of .out array syntax. They're updating that for the next version, I think. But doing this, you very quickly can just get back an array of the detected verbs and nouns in your text, which is obviously what we want. And from this, we can start to infer what the player actually wants to do. So, like I said, we define the commands internally in the engine and their aliases. We want to create essentially a lookup table of different aliases to the base commands, so kind of like a reverse object. So we do that in the engine, and so we can say that, okay, if the player has typed acquire, or if we detect that the verb in this sentence is acquire, they actually mean to get something, and we can use that base command to then start to perform our logic. We do need to let Compromise know about those aliases and verbs though, so Compromise is very extensible. We just provide it with there's a callback you can call just extends. It gives you the dictionary and everything it knows so far. This is kind of this text is kind of blown up a little bit. In reality, in the engine, I have this disgusting reduce function to kind of like do this all in one liner, but essentially the spirit is the same. We feed it all our base commands, aliases, and tag them as verbs inside Compromise. And then same for the nouns that we have for all our objects and entities, but we just tag them as a noun and then just let Compromise know that these are verbs and nouns so it can start to pick them apart when we give it text. So the parse logic, broadly speaking, is pretty much what I just showed on the slide before the last one. We feed the input text from the player to the Compromise library, which I've imported as NLP here, plug out just the first verb and noun. If we don't have that verb, something that matches that verb in our lookup table of commands, we know we have a valid command that we can respond to, so we just bomb out here, we tell the player you can't do that. Otherwise, we know what base command they're trying to execute. If it's a navigation command, as in if the entity we're in has a to entry with that command, we try to navigate the player to that relevant location. If not, we need to know what they're trying to do and what they're trying to do it on. So we basically iterate through the things array for the current location and the player's inventory and find the first subject that we having those lists that matches the noun they've entered, and then we know what command the player's entered and what they're trying to act upon, if anything, and we can start to do basically a big switch statement that will handle that logic for us. We've already handled the navigation, so this is obviously truncated code, but we do have fallbacks for, we can't go that way. If the players try to navigate to somewhere with a known navigation command, but we didn't navigate, we know that they can't go where they're supposed to be going. Other things are just a matter of detecting whether, let's say the get command, for example, detecting whether we can actually move the item, if it's not fixed to the location, if it's present, that kind of thing. If we can't, we just tell the player they can't do that. Obviously, instead, if they can, we delete it out of the things set and add it to the inventory set of the player, so we're just swapping the item. It's interesting, this API is actually what we're going to expose to the authors for defining logic, and I arrived at some interesting kind of assumptions about how this was supposed to work. I was going to write essentially an array API. I was thinking, okay, these have to be unique. I have to make sure that you can't delete something out of the array, that kind of thing. And so I was going to write a wrapper around arrays and provide a bunch of custom logic. Then I just realized we've got sets in JavaScript now, and they have built-in uniqueness, and they have add, has, and delete as methods on them. So it's kind of a free API that is vaguely human readable. So just remembering that these things exist in the browser now sometimes can be a challenge. So that's the crux of how we handle built-in commands, and there's entries in the switch statement for things like examine, for look, that are all calling internal logic and manipulating these items. So in summary, that's kind of the extent of the parser so far in the engine. We use compromise to get the verb and noun. We look it up against our known commands and verbs. We update the game states in a switch statement based on what the player wants to do, and that's really how the player interfaces with the game world. Obviously there's a lot more I could do there, which I'll mention in passing at the end, but we want to be able to expose a means for authors to now write logic for themselves. This is essentially all the player can do currently with this engine. They can move around, obviously, they can pick up items, they can examine things, but the items don't do anything. We haven't provided an inbuilt way or any kind of inbuilt logic that will let a player use an item or drink something. The game doesn't know anything about how to look a door, that kind of thing, so we need to provide a way for the players to, or for the author to be able to very quickly define this logic by being able to expose things like custom commands, being able to intercept what the engine normally does and be able to change that if they want to. Hooks for different parts of the game process, like when we describe a location, can we intercept that? When they try to move, can we intercept that? And access to obviously all the entities in the game and the means to print to the screen, so they can kind of extend the engine through defining their own logic. I mentioned at the start that we do have built-in hooks in the engine that are called different parts of the game logic. On command is called when the player actually enters a known command. If they enter a command that doesn't exist, we don't go any further and this doesn't get fired. We pass in the command that was typed in and the subject, and so the author can then start to do things with those. On go to is when someone tries to go to another location in the game. We can stop that at any point. All these hooks can do something before, they can do something after, and they can actually stop the initial behavior altogether. On look is a hook for when the current location is described, and on turn is when the internal state has changed in some way. If you do a val command, if you remember in the bomb game, it was going tick and tock, tick tock. That was happening every turn. If I was doing a val command, like examining something or trying to go to another location, the game was resolving that behavior, but then it was incrementing or decrementing a counter and printing something out. That's through the on-turn callback. So each of those callbacks is getting what I call the game API, which is an internal object that basically encapsulates most of what the engine can do. It can report back on any entity, give it the raw entity object, so that the author can then do something with it. We can trigger a navigation event with a go-to command. We have getters that can access the player's current inventory, the current location. We can actually do a pause, which will pause the output for a minute. You saw when I tried to pull the wire out of the bomb that there's a brief pause between the text. That's using that function. We can print, obviously, to the div, just output paragraphs, same way the game does internally, and provide CSS classes to it for some extra color. And we can get access to the game state. Also, like I said, a lot of the arrays that we're defining in our entities are converted to sets by the engine to let us have this kind of free API of add, delete, and has, that kind of thing. I still kept the essential kind of object literal and basic array definition format for the authors because there would be no fun having to declare sets and maps if you're just trying to create like a tavern or create an item or something like that. So it's a glorified JSON definition format, but with a bunch of extra functions and things we can use, and we can use the full power of JavaScript to define our entities, and internally we convert them to things that will make more sense for the authors to use. So a couple of examples. Classic example in a text adventure is that somewhere is too dark to actually do anything. So This on command fires again globally whenever any command is entered, a valid one at least. So if a player enters the examine command and the metadata of the game location that you're in says that it's dark, if a boolean set there, then we'll just print it's too dark to see, and we return false. We return false from this function. It stops the default behavior, so the examine doesn't happen. It doesn't matter what you were trying to examine. If the location is dark, you can't see anything. So theoretically, then you would have to get like either a lantern, make it less dark, or go somewhere else to be able to examine your items. By the same token, we can return a function from onCommand instead. It kind of took a bit of inspiration from React use effect here. You can return a function, and that will let the default behavior happen, in this case the examine, but then you can return a callback that will be called straight after that. So in this case, if the player examines the toolbox, we immediately print before the examine command runs, you begin to inspect it. Theoretically, the examine command will then run and describe that toolbox with whatever its description is, and then after that, it will execute this function just to say, oh, something's falling out of the toolbox, and we'll use the game API to add a wrench to that location. Now, the flaw in this logic currently is that there's no check to see whether this has been done already, so theoretically, a wrench falls out every time you examine the toolbox, so you need to have a boolean in the metadata somewhere that will be able to be set as a flag to false, and just execute this check once. Custom commands, like I said, the game doesn't know how to drink anything or how to, pull the wire or anything like that. We have to define our commands. So let's just define them very similar to the way that it is done internally. You just create a commands object, which you can set a bunch of aliases on. Here I've got drink and all the aliases I can think of off the top of my head for that within reason. And then on command, you can start responding to that object. If the command was drink and you're trying to drink a potion, print something, change some state, and this would be kind of where we do the tavern tankard thing, that kind of example. We'll assume that the potion here is describing its state through its description. It's either full or empty, and by changing it here, next time we examine the tankard, it's empty, or examine the potion rather. Navigation events, obviously, we need to be able to intercept. So on goto is called globally whenever there's any location change attempted. In this case, the classic example is a locked door. We can't get into the location if it's locked. Simple example here is just we've set some data on the destination, which is another entity, just a location somewhere. To say it's locked, just a boolean is true. So this logic just checks if for some reason the player doesn't have a key in their inventory and where they're trying to go has some data saying it's locked. It stops them. It says you need a key to get it in, returns false, and so the navigation change doesn't happen. We stay where we are. There's also, because a lot of this logic is going to be tied to a specific location, I've added an onGoTo that can be applied to specific entities. It works exactly the same way. It's just it will only get called if you're trying to go to this location. It gets called after the global callback, and the same thing applies. If you walk into this location carrying a certain item, it will do the whole thing it normally does. It will take you there. It will describe the location, but then it will also print, "Hey, well done, you completed your objective," and end the game. So you can really see how through this kind of basic API, where we've just exposed most of the game internals, in a fairly terse bunch of commands, you can start to build a pretty complex logic, and that's really everything the engine can do, but you can take it pretty far. Of course, we're not doing TypeScript here, and there's not much in the way of compile time safety for authors. We refer to entities by string IDs. If they try to stick a function or try to pass a number to like one of the lists, it wouldn't stop them. The game would just kind of blow up. But with a bit of metaprogramming, we can try to at least ensure a little bit of runtime safety so that when we're debugging and testing, we know a bit about what's going on if we've done something we shouldn't have. So I've used a proxy to wrap a lot of the entity collections. So remember, things like the entity things and the entity tags are converted to sets internally when the engine picks them up. They're also wrapped in a proxy, which basically, this is kind of weird code, but it essentially sets a handler that will be called whenever we try to call any of the set's internal methods, like has, add, delete, that kind of thing. By default, it will just fall through to let that method execute fine, which is the code at the bottom part of the handler. But we do check that if we're trying to add something and it's a non-string, we can just throw an exception at that point. So it's kind of a guard around a JavaScript built-in set to say, hey, you try to add a non-string to this entity list, that's probably going to blow up in your face. Now, that will only happen when you hit the piece of code at runtime that actually the game is trying to do that on. But again, it's not type safety, it's not like proper compile time checking, but it will hopefully be a debugging tool if you're playtesting at the time. Anything we can do to kind of make the entity API a bit less, a bit more safe and a bit easier to use, I guess. So other bits that I kind of did a rewrite recently. I'm probably going to do another one because the code is a bit kind of all over the place. But things I have had at some point but need to re-add are things like command history. We love our terminals. We love our CLI databases. So if I've typed something, you know, when you have like a git status, like somewhere within like the 20 items in your history, instead of typing it again, you just go back up a bunch of times. It's something similar to that for your command history. Being able to do multi-command input, like get the cake and eat it, that kind of thing. And it was also something I used to have. It refers to the last known subject that you interacted with, so you can do things like get sword, throw it, that kind of thing, just having to type throw sword again. Also, if you're printing a lot of paragraphs out in the page, there's a chance that things could scroll up past your view before you've had a chance to properly read them. So I want to add an intersection observer where you can basically watch for the first paragraph that was printed in the current set, and if it's hitting the top of the screen, you probably need to pause the output and let the player read it, and then maybe they can tap or click continue to let it read on. Just little quality of life features. One of the cool things about text adventures is that if you're into UX or into improving user experience, there's a lot of leeway to add a lot of really good convenience features for the user, and it can be done very quickly because you're not having to mess around with graphics or complex UIs, it's just a bunch of text coming in. In terms of what I want to do in the future with this, it could go any direction. Obviously improve the parser. There's a whole strain of machine learning logic now around building these things, which I'll talk about a bit just in a couple of slides. I've seen people build these into Alexas. You know, so Alexa describes the location to you, and you tell Alexa where you want to go, that kind of thing. Procedural generation, instead of manually defining these entities, we could use a machine learning algorithm or a generator to basically spit out randomized or generated locations that you can then interact with. Writing bots that play these games for you. Autocorrect for, you know, if I type a command and it's not right, maybe I get like a suggestion, that kind of thing. There's all kinds of stuff we can do here. So let's briefly go back to our demo to finish and see whether I can get out of the room. So please feel free to shout out instructions here. So we're trapped in the basement, we can't get out. There's debris on the floor, there's a door in the east wall. We have a ticking time bomb. Any suggestions? Search the debris, okay. Sifting through the rubble, we uncover a rusty crowbar. So if I look, there's a crowbar sticking up from amongst the debris on the floor now. Shall we grab it? Okay. So we're carrying a crowbar. What now? Anyone else? Paul's going to solve this by himself. Okay, so, okay, we'll say force door. We force the door open with some effort. So we go in. We can see a toolbox. So we examine the toolbox. Something's fallen out. The bomb continues to count down, obviously, while we're doing this. So we can see a pair of wire cutters. That sounds like it might be handy. Will we grab those? Sorry? There is no visible means of escape, apparently. We're stuck here. Totally. So we'll leave this room. We're back with the bomb. What will we do now? Cut the wire. You snip the wire, hold your breath. We did it. Well done. Congratulations, everyone. So that example was thrown together in about 50 minutes. And it seems fairly straightforward, but there's actually quite a lot of complex things going on there. There's items that are not visible until you examine certain things in the environment. There are commands that respond in different ways depending on what items you're carrying. There are locked doors we have to open. Again, examining items leads to things falling out of them, that kind of thing, all done with that very basic API, which you saw defined. So I think it's enough to drive a decent looking and decent functioning text adventure. All in JavaScript with, we're writing JavaScript. To define this adventure, we're still slinging around functions and object literals and arrays and all the good stuff we love to write in JavaScript on a daily basis. So why did we do it? Again, low barrier to entry, easy to do. It's just text at the end of the day. We can use our existing JavaScript skills and build some new ones, hopefully, in the course of building out games like these. Some of the coding challenges for engine writers are definitely worth your exploration, particularly in the realm of like how we parse the input. How can we have more complex inputs? Like it would be great to be able to say, search the debris, then pick up whatever I find, anything useful, that kind of thing. We don't want to get to the point where the game plays itself, but making it more expressive narrows the gap between what the player can do and what the engine tells them. You could have the best writing in a text adventure game, incredibly descriptive, extremely evocative prose, but if a player is responding to it with get bar, it kind of diminishes the experience somewhat. Also, we do this because we get to be very familiar in a paradigm and an environment that we're intimately familiar with, hopefully, in the browser. Add new features very easily. You can just hack on this. This is a night project for me now. This engine was put together over nights and just hacking on bits here and there, having ideas, seeing if it works, and it's just a very joyous experience to have a side project that you can just very quickly iterate on. And yeah, it's fun. At least it's my kind of fun, I think. And hopefully it'll be your kind of fun too. So the text adventure code is, I haven't made that public yet, but I will. It's on I haven't come up with a name for it either. Internally I call it Engine. It's got, the repo has a very snappy title of NIDC 2021 Text Adventure. I will be adding more new features and probably doing a rewrite again pretty soon. All those resources there are a bunch of really interesting stuff that will cover everything from online resources for reading and playing these things, some tools, common popular tools if you don't want to build your own engine, if you want to have a go at doing this yourself. There's a bunch of, there's Twine, there's a bunch of other ones there. There's a really good documentary on YouTube which kind of covers the entire history of the genre and the evolution of text adventures in a much more comprehensive way than I was able to do here. And also, if you Google text adventure and then open your DevTools and read the console, it will give you a text adventure to play because Google do things like that. I think it speaks to the permeation of the genre and just how much it's still very much loved and still an interesting thing for a lot of people, especially engineers. So they say there's a book in everyone. I'm convinced there's at least a small text adventure in all of us. So whether you use my engine, whether you build your own, whether you use one of the existing tools to have a go at it, I would love to see what any of you come up with. If you are building something, maybe you're already doing it, let me know. Let everyone know at DevConf and BelfastJS, and we'd love to see what you're doing. But for now, that was Go North, Get Sword. Thanks very much for listening. Cheers. Got time for questions? Shoot. I definitely, yeah, so the question was, is there a way to manage internal state such that we could basically ship games and do save and load games? Absolutely. Everything is, game state is stored internally in objects, so your current location, what your inventory is, your command history could typically be stored there as well, the state of all the entities, that kind of thing. So theoretically, with a big enough serializer and maybe some crypto to put that in a form which is less open to exploit, you can distill that down to a text file, download it, and then be able to rehydrate it at a later date. Obviously, you could then save it to a server if you wanted instead. Just a note on the crypto, though, I don't think I would obfuscate these saved data. If someone wants to cheat, let them cheat, right? We're not doing online banking here. If someone is looking to exploit your game, they're still engaging with the game in some way. It's better than them not playing at all. So anti-cheat mechanisms in AAA games is one thing, but if you're just writing a text adventure engine, I probably wouldn't go to the effort of encrypting that data. But yeah, definitely possible, definitely something I want to try, because it'd be great then you could just distribute the engine and the game as a single format, and actually it would be cool if the engine then, no, that thought doesn't make sense, never mind. Everything else you said was great. Any other questions? Paul? Absolutely, yeah. Well, yeah, I mean, so the question is, could we take this farther into more of a graphical realm? So the on-turn hook's probably a good state for that. I actually had an example where, or on go to even, every time the location changes, you could just stick a data attribute in the body of the CSS, or the body of the HTML, because it's all obviously still JavaScript in the DOM. And then you could write CSS to hook into that. So like if data attribute was tavern, you could display a picture of a tavern in the background image, that kind of thing. Or yeah, you could probably have a hook that would then change the font color, that kind of thing. It very quickly can add up, yeah. I mean, roguelikes, which are still all the rage now, kind of sprung up shortly after the advent of early text adventures. As soon as these text adventure terminals started to get ASCII graphics, the adventure paradigm shifted into displaying little dungeons, walls and floors, and the @ symbol was a player, and that spawned a whole other genre as well. And roguelikes and roguelites are still influential today to a point which is almost a matter of parody now. So Yeah, I think that the same sort of general state management applies. There have been real-time text adventures as well. Even very early on, I think there was it might have been The Hobbit or Lord of the Rings. If you were just reading the text, Gandalf could just leave without you having to without you even typing something, you have to go follow him. So there was almost like a simulationist aspect going on. And some of these engines can get very simulationist. They have built-in rules for containers, even like how much light can shine through a container, things can go into the containers, different weights of things, different materials, how much sound they make, all that kind of thing. That's way overkill for what I'm trying to do here. And also, I don't see how that helps non-technical people who then have to learn an entire functionally an API to make these things work. I think something where the idea of a minimal API surface area kind of picked up again from the React docs recently, and I think it's true for this kind of project. Just expose enough for the thing to be useful, and then let the author worry about the other bits. And I mean, a plugin architecture for this thing would probably be very easy to do because we've got those hooks, we've got the game API. We just need to basically build functions to take advantage of them. So that was a really long, rambling answer. I could do this all night. Anyone else? All right. Thank you very much. Cheers. Thanks, man.
Oh, that's bright. God. Thank you very much, everyone who came. A huge round of applause for our amazing speakers. A huge round of applause for the people from NIDC. And a huge round of applause for yourselves for coming out. Go on, clap yourself. There we go. So that's it for tonight. We've got more plans and events coming soon. Check the socials, Meetup, Twitter, wherever you can find us. BelfastJS.whatever.com and all that. Yes. What's JS? Yes.
Better this and us.
Yeah.